Remember, this is our function notation. So we have f of x. My function is f. This could be another letter. It could be g, it could be h, it could be r, it could be s, whatever we decide we want to make it be. This identifies your variable that's going to be in your function. So if this is my function and I want to find f of -4, what are we going to do? Plug in -4. So is the negative in front of this x squared being squared? No, it's kind of like order of operations, that's multiplication. So I'm going to have a negative, and then I'm going to plug in -4 in place of my x. So -4 squared plus 5 times -4 minus 11. So order of operations, -4 squared is 16 times the negative gets me -16. 5 times -4 is -20 minus 11. So -16 minus 20 gets us to -36. -36 minus 11 is -47. So I'm going to write my answer as f of -4 equals -47. Do you remember what that looks like as an ordered pair? If I had to plot that on a graph, it would just be -4, comma, -47, right, Kyle?
Something I'm not really confused about, and it's in the past I've done with negatives with exponents, and it keeps it at a negative.
Right, because you need to put parentheses around it. If you don't, then your calculator is going to think of it as a negative times. Like it'll do order of operations. So we'll square just the number first and then take the negative of it. So if you're plugging it into your calculator, put parentheses around your negatives. Okay? Or just don't even put the negative in if you're going to square it, because you should know that it should always end up being positive. Sometimes I do that just to give myself one less step. Okay, so we've got that. All right, so now let's actually add and subtract functions. So, new notation. Instead of just saying f of x or g of x, we might be adding or subtracting two separate functions. So if you see f plus g inside the first set of parentheses, that means I want to find the function f plus g for x. And all that means is we are going to add function f and add function g to it. Which you already know how to add polynomials because you did that in section 2. So it really shouldn't be that complicated. It's just now we're turning it into function notation. Same thing for subtraction. If you see f minus g of x, then all you're going to do is you're going to take function f and subtract from it function g, which you already know how to subtract polynomials because you already did that in section 2. Now we're just turning it into function notation. Okay? So what's going to happen is in your example, you're going to be given 2 or 3 or 4 or however many functions in the given part, and then you're going to use that to find your adding or subtracting of the two functions. So if we let f of x equal 3x squared plus 8x minus 6, and we let g of x equal negative 4x squared plus 4x minus 8. I want to find the sum of those two functions, and I want to find the difference of those two functions. So it's as simple as just adding them together and subtracting them. Let people write it down first, Carrie. I'm waiting. I'm pausing on purpose. Okay, so f plus g means we're going to take function f, which is 3x squared plus 8x minus 6, and I'm going to group that together with some parentheses. And I'm going to add to it negative 4x squared plus 4x minus 8. Because we're adding, it's just as simple as combining like terms. So let's add the x squared terms first, the quadratic terms. So 3x squared plus a negative 4x squared is going to go to a negative 1x squared. 8x plus 4x will combine to make 12x. And negative 6 plus a negative 8 gets us a negative 14. But we got to make sure we watch our notation because we're in function notation. So we need to write f plus g of x is equal to that. So I know what composition of functions I did. So here I added the two functions to get the new function. Okay, so now let's do the same thing for subtracting. So instead of adding my two functions, we're going to subtract them for part B. Now again, it's up to you. If you want to mentally do the math of subtracting and you think you can subtract things correctly, feel free to do that. Me personally, I like to turn my subtraction into addition and then change the sign of everything in the second polynomial. So if I change this into a plus, then that's going to change into a positive, that's going to change into a negative, and that's going to change into a positive. So now I can just add, so f minus g of x is equal to 3x squared plus a 4x squared gets me to 7x squared. 8x plus a negative 4x would be 4x. And negative 6 plus 8 is 2. Again, if you want to just think subtract, feel free to do that. 3x squared minus a negative 4x squared would go to a plus plus. That would get us to the 7. 8x minus 4x gets us to the 4x. Negative 6 minus a negative 8 plus plus, so that goes to a positive 2. I'd still get you there. That's up to you and how you want to do that. Okay, adding and subtracting functions, easy enough? Okay, so where it gets complicated is when we get into compositions of functions. Do you remember those open dots from Algebra 2 last year? G of f of x. So a composition of a function is when you put one function in place of another function. This is not multiplication, it's not a closed dot, it's an open dot. So we say it g of f, or f of g, whichever order, or h of r, whatever the functions are, they're in there. So if I need to find g of f of x, that means I'm going to take whatever the f function is and put it in place of the g function. A lot of times, me personally, I'll do a little arrow. The second one always goes into the first. Like that kind of helps me mentally think, okay, I got to put the second one into the first. So whatever one is listed second goes into the one that's listed first. You guys remember doing these? Kind of, maybe. All right, so if I give you these two functions, f of x equals x minus 4, and g of x is equal to x squared. And we've got to find f of g of 3. Well, we don't have an x variable. I have an actual number that I need to evaluate for. So if I see something like this, you've got two options. You could do the composition with just the number first. You could put that value of 3 into your g function. What do we get if we take g of 3? Get what?
9.
Yeah, because it would be 3 squared, so it would be 9. So now I'm taking my g of 3 value, which is 9, and I'm going to put that in place of my f. This is what the notation looks like. So what we just did is we did our g of 3, and that's going to go in place of my f. That turns into that. We just found g of 3, and we said that it was 9. So now what is the f function evaluated at 9?
9 minus 4.
Yeah, so that would be 5. Good. So my final answer, notation-wise, f of g of 3 is equal to 5. See how that works? What if we did it a different way? So let's ignore this one. What if we had g of f of, I don't know, let's go 2. How would we do that? The 2 is going to go into which function first? The f, right? So that means we're going to evaluate f of 2 first. Once I get that, I'm going to plug it into my g function. So what is the f function evaluated at 2? Negative 2. So now I'm going to evaluate my g function for negative 2, because f of 2 is negative 2. So what is my g function evaluated at negative 2? 4. Good. So my final answer, writing out the correct notation, g of f of 2 is equal to 4. Okay? So it's pretty easy when you're dealing with just in value. Where it gets complicated is when you just have the x and you have to come up with the new function that is the composition of something. And then maybe you have to square something, which means you have to FOIL it or double distribute, whichever way you call it. All right, so let's do one like that. Nope, come back. Where are they? Seriously? I don't have any that have x's in there? My goodness. Let's make this one be an x. Pause. All right, we'll stick with the same functions to make our lives easy. Let's find g of f of x. All right, so now if we rewrite this, I want to find f of x, and I'm going to put my f of x function in place of the g. Or if it's easier for you just to think about, f goes into the g. So here's my g function. I'm going to physically put in place of my x, my whole entire f of x function, which is x minus 4. So that becomes x minus 4 squared. Wrap your brain around what just happened. We physically put my f of x function in place of the x in the g function. So now how do we simplify that? Well, that's the same as x minus 4 times x minus 4, right? What do you get when you multiply that out? First times first gets us an x squared. Then we have a negative 4x and negative 4x with our inner and outer, so a negative 8x. And the last negative 4 and negative 4 goes to a positive 16. Good. So we get g of f of x is equal to x squared minus 8x plus 16. What if we wanted to do the reverse? What if we wanted to do f of g of x? Can I erase this? Okay, so let's do f of g of x. Still using the same functions. So that means we're putting the g into the f where I see an x. So this is a little bit easier because what would it look like? So instead of my x, I'm going to put in x squared, and then I would just bring down the minus 4. I don't have to do any simplifying to that, so that means I'm just done. What if I wanted to find f of x? So plug an f back into the f. What am I going to put in place of this x? Yeah, so I'm going to have an x minus 4 going in place of this. Now you have to bring down the rest of the function, which is another minus 4. So that would simplify to, yeah, x minus 8. So f of x would be x minus 8. What would be g of f, or of x? G of x. Kyle? Yeah, because it would be 2 times 2. X squared would be x to the 4th. Good. What if, I'm going to give you a good one. You ready for this? What if we had to do g of f of x?
So we'll be plugging f
I should make
to
my
f
little,
and then of g.
yeah. So we first need to do f of f, which we did that. What was f of f? F of f was x minus 8. Now plug that into your g. What would that look like?
X minus 8 parentheses squared.
Good. X minus 8 parentheses squared.
Then FOIL.
Yep, so x minus 8 times x minus 8 gets us to x squared minus 16x plus 64. So we can do as many compositions as we want it. I could then have put an f in front of this for fun. You don't have to do this in your notes, because why not? What if I put another f in front? Then I would put this in place of my x up here. So the only thing that would add to this expression would be a minus 4, which would then simplify to plus 60, right? Okay? All right, so you think you got compositions? Do you think you have adding and subtracting functions? All right, so the last thing we need to cover is going back to our graphs of functions, which we already kind of talked about this when we were talking about domain and range of graphs. So now what you need to be able to do is identify a basic linear, a basic quadratic, and a basic cubic graph, and what the domain and the range of them would be. Okay? So basic polynomial functions. So let's first start with linear, because that's the easiest. So our first one is going to be linear. Our most basic linear function is going to be f of x, remember that's the same thing as y, is equal to x. If it helps you, for your brain, think about that as just being a y equals x equation. Because it is the same thing. It's just function notation versus in a linear equation. What would the graph of that look like? We would have a y-intercept of 0, and my slope would go up 1 over 1, right? Or down 1 over 1. So that would be my graph. What would be the domain? Remember, your domain is all your x values. Yeah, it's all real numbers, right? So negative infinity to positive infinity. What would be your range? The same thing. Good. All right, so hopefully you can identify what a linear graph looks like. It's a straight line. The only straight line that's not a linear function would be a vertical line, because remember, vertical lines don't pass the vertical line test, so that would not be a function. All right, so we've got linear. What about quadratic? What does quadratic look like? It is a parabola. What's the exponent going to be on a quadratic term? I have an extra C in there. Quadratic. Quadratic. So that would be f of x is equal to x squared, would be our most basic quadratic function. And that's a parabola. Now, probably the easiest way to come up with the graph, so we have exactly the right, is make your t-shaped table. You can put y here. You could put f of x there, because that's the same thing as y. Either works. If I pick, let's pick a -2. Plug in -2, what comes out? 4. Plug in -1, what comes out? 1. Plug in 0, what comes out? 0. Plug in 1, we get 1. Plug in 2, we get 4. Right? So if I plot those points, -2, 3, 4 is there. -1, 1. 0, 0. 1, 1. 2, 4. Oops. Did not do a very good job of connecting. When you make your parabola, you should have at least 5 points on it. You should have your vertex at the bottom and then 2 on each side, so you know you have enough information. Okay. What's the domain? All real numbers. What's your range? Yeah, good. Here our range is, we're including 0, so put a bracket around it, to infinity. You guys know what a cubic graph looks like? An S, swervy, like a kind of weird S. All right, so cubic is going to have what exponent? Yep, so f of x is equal to x to the third. Let's again make a quick t-chart so we know that we get precise numbers. If I do -2, -2 to the third power is what? -2 times -2 is 4, times -2 is -8. -1, -1 times -1 is 1, times -1 is -1. 0 is 0. +1 would be +1. +2 would be +8. So now if we graph those, -2, -8, 1, 2, 3, 4, 5, 6, 7, 8. -1, -1, 0, 0, 1, +1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So yeah, you kind of get that sideways SE curve. You want to call it an S, not quite an S, but it's a curve. You have an inflection point in here in the middle of changing directions. So what's your domain? All real numbers again. What's your range? All real numbers again, also good. Okay, and it kind of stays in this pattern. If you have a degree that is even, so if we went to quartic, it's going to look like a parabola. It's just that the bottom of it kind of flattens out. If you went to a degree of 6, the U flattens even more. If you went to a degree of 8, then it flattens even more. But it's still going to keep that parabola shape. So your domain and range kind of stay the same each time, unless it starts shifting down. If you did a 5th degree, the shape is going to still stay looking the same. It's just going to stretch up a little bit more because your numbers are going to be higher. So your domain and range is going to stay the same. If you went to a degree of 7, your domain and range is going to stay the same. Okay? So if we think about it, if I have an odd exponent, linear, odd, cubic, quintic, 3 of 7, our domain and range is staying all real numbers. If I have an even exponent, my domain still is going to stay all real numbers, but your range is going from 0 up. Okay? All right, so would you be able to graph any of these functions, even if I added like a 2 in front of that? Okay. All right, that's all I got for section 5.3.